Very. So, hi, welcome. Um, Anybody that knows me knows that this is a topic that is very dear and near to my heart.
What, shrinking code?
Yes. My name is Beat. And I'm from Switzerland. No, my name is not Beat, but I am from Switzerland. And for you that is easily distracted by words that are not correct. So integral database design for me is very, very important, especially when we talk to the development community of PHP MySQL projects. For some odd reason, we're very good at coding in PHP, but we always look at the database afterwards as we need to have a database, so we'll use whatever we have. One of the biggest problems that I always see with development is we tend to think in PHP when we do database design, which leads us to forget that the database itself can do a whole bunch of stuff significantly faster than what we can do in PHP, okay? So this is precisely what this talk is about. The agenda is very simple. I'm going to introduce myself. I'm not Beat. We'll talk to a topic that is near and dear to me, which is the nested sets and the computations that happen on the nested sets. I'm very happy that Nicholas is here because that's going to be implemented. So you don't really, if you don't want to listen to the nested sets, that's perfectly fine because very soon it's going to be built into the FOF. And then a whole bunch of little tips and tricks of what to think about when you do a database design, when you do a query design even, okay? I am Eli Ashkenazi, originally from Switzerland. For the last 10 years, I've been living in Cleveland, Ohio. Run a smallish web shop. Large data sets, when I'm talking about large data sets, I'm talking about data in the terabyte sizes that we shrink down. So for larger clients, GE and Toyota and stuff like this. What I have to tell you, I love data. And even more so, I really love Joomla. So if you want to talk to me either about data or Joomla, I'm definitely willing. So that's very simple. That is who I am. So let's start with nested sets in general, and we'll go over what it really is and conceptualize what nested sets really are. Can you see? More or less. You're good. Essentially, nested sets are a way to visualize a hard concept into manageable parts. So of course, on the right-hand side, so this is essentially the female wardrobe is really a nested set. And everything belongs to something else that then leads to something else, that then leads to another choice. So for all the male audience, we have to leave because nested sets are not for us. For us, it's very simple. It's a one line. When we think in Joomla terms, so of course the simple way to understand nested sets is the categories and the articles, right? So the category manager is actually a nested set, and then we have a whole bunch of leaf items that currently are really handled a bit less than optimal, right? Because one item belongs to one category, which doesn't necessarily make sense. But it's viewed as a leaf category. I really want to make sure that we understand to dispel that notion and really think about entities not as leaf nodes in a hierarchy, but as entities that are not necessarily connected. Root node is very simple. Then we have left and right. Left and right values. Anybody here is familiar with the nested set? Okay, perfect. The whole purpose of the nested set is that every node gets assigned two numbers, a left and a right value. And the way this works is it starts at the root node on the left and continues to trace the whole root as much as possible following the outline of the root. So we're going down on the left, right? And at this stage, we can't go up because there is part of the structure that of the tree is actually blocking it. So we're going around and continue up and so forth. And fill it up just look 1, 2, 3, 4, 5, 6, etc., etc. Very simple. The advantage of this is, so the base knowledge that you always have to have is that the root item is the one that depends on the implementation, either a 1 or a 0 as its left value. Okay? So the lowest value in your tree is really the root item. When I'm saying the lowest value, in theory, this could be a root of a different tree altogether, but of the tree that the lowest value of which is 22. You understand what I'm saying? So when you look at the whole tree, it's 1, but you can actually look at subtrees, and I'm already preemptively giving you some thinking power to how actually to define a tree and a subtree, where the subtree exactly is defined again as the lowest left value of whatever subtree that we're addressing. Now, there are interesting, due to the fact that every node has 2 numbers assigned to it, there are very simple ways of doing a whole bunch of calculations that seemingly are expensive calculations. As an example, if you want to know how many categories your tree has, right? It's a very, very simple formula. All that you do is you take the 2 values of the root node, right? So it's the right minus left. And then if you have 1 as your left value, you add 1 minus 1, or just very simple, and then divided by 2. And you have the total value of all your nodes. So in the category manager, as an example, if you want to find out how many categories you have a dashboard or whatever it is, in whatever type of hierarchical data, and you want to know how many nodes you have, this is a very, very simple and fast calculation instead of just doing a table scan and a count, which is what we usually do. Right? The other function that we really use quite often is to find whether or not this is the last category or node in the tree. And that's again due to the fact that we have this continuous numbering scheme. Everything that is its left and right value is off by 1, right, is going to be a leaf node. Right? Because that's at the end of the tree. That's the only possibility is if they're 1 apart, is if they're a leaf node. We'll talk a teeny bit about optimization of leaf nodes or any type of queries in general. Usually, the thought is right minus left equals 1. So for indexing purposes, never do that. Always try to use the variables on each side, because now we can actually index this. This is fully indexed, as opposed to the left minus right, which is a variable within the indexing scheme of MySQL itself. In addition, never do select star. Yise, who's giving another talk, is actually doing an interesting implementation. And by the way, this is the biggest, my biggest kick out of this is when we talk about database, and then all of a sudden people come back to me and say, oh, I implemented this and this, and I actually made it better. So if you have a better idea, absolutely let me know. I'll push that out as well. So select star. So Yise, what he's doing is he's looking up all the column names, stores that in cache, in Joomla cache, in an array, pushes out the stuff that he doesn't want, and then just does the select actual values instead of select star. Select star is a very expensive query, and we'll actually discuss that a bit later as well. Let's go back to the nested sets. And what we have here is a very easy implementation of figuring out whether or not any category is a subcategory of another subcategory, or getting a subtree. You remember what I said before, that the left value could be the root of a new tree. That's precisely what this is. So essentially now, due to the fact that we continued with the numbering scheme, I know that from this node, any number that I'm finding a left value that is between 22 and 35 is part of that of that tree. Does that make sense? So this is very simple to find a subtree, right? Very, very simple. Subtree, just to find what the children's are, all the descendants. It's exactly the same as previously. We're just adding 1, which is the left value, original left value. We just add 1 to the original left value just to get the subtree. Why am I telling you this? Because unfortunately, this is actually I think a 2.5.x type of site, but it's exactly the same thing in 3.3. There are a whole bunch of additional information in the Joomla database tables that are really not required, that are very, very easy to compute and are significantly easier to manage than the current implementation. Okay, so when you go home and actually create a component, anything that actually uses a database table, make sure that you don't do double work. As an example, the path, right? So this is the actual calculated, and the best part is, in 3.3, they have a note in the table that says, this is the computed output of according to alias, which means it's already known that there is a possibility of doing that computational, but it's still hard-coded, right? What is the problem? Very simple. Just imagine here we have articles and case studies and articles as 2 items, right? Let's say we are changing articles to be called no articles, items. So this is simple because we just have 2 rows. But if you have a big tree and you're changing the root name, you're going to change the records of all records that have that computation in it for 1 change. That's absolutely insane, right? So how can you do that computationally? The path to a node is very, very, very simple. The way you have to think about it is we're eliminating everything to the left of it, and we're eliminating everything to the right of it. So we started with the last node that we were actually, so this is essentially the breadcrumb, right? So we're trying to understand, how did we get to sandal? Let's see, no. How do we get to sandal? If you're thinking that hierarchy again, essentially what we are saying is we are using only the items where the left value is less or equal to my current left value, which means I delete everything that is to my right of the left values. So think about it in two trees. And then the same thing goes with the right values. I need to make sure that everything that is bigger than the right value. So as an example, due to the fact that we have left is smaller than 4, all of these items are out, because all of them have a left value that is greater than 4. So the only thing that is left after this already actually here is precisely this path. Right? Same thing goes for right. So if the path would be from here, 24, 25. I want to know what's the path to 24, 25. So I'm saying, I'm kicking out everything that its left value is less than 24, which means this whole thing is out, right? Because its left value is more than 24. This is still staying in. This is still staying in, because its left value is less than 24. And then I'm saying, anything that is greater than 25, it has to be greater than 25 on the right side, which means all this stuff is out. And all of a sudden, the only thing that you're left with, and it doesn't matter how big this tree is exactly that breadcrumb path. So, when we're talking about in this instance, right, of this illustration, if we want to have the actual path printed out exactly as we have it in the database with the slashes, select group concat. Group concat does precisely that on a table, on an array, or a result set. So concat everything with a separator of a slash, whatever you want this to be. So if we have this, and this is from the, oh, here we go. Where is path? The computed path of the menu item based on the alias field. Right, so in the menu, in the table idea, they're actually talking precisely of what they're supposed to be doing. It's not done though. So messaging read private message, due to the fact that this is left 20 and right 21, if I have it without the left +1, which means without the root, that includes the root in the path, and that's calculated messaging / read private message. Right? If you want to have the root in it, so you just omit that left plus greater than 1, and you have root / messaging / read private message. So this is a very, 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 very basic and very inexpensive query that you can run, eliminate the path altogether, and you don't have to worry about updating and updates on large data sets.
But if you're doing it for 25 different categories, because you want it for the router, all in one go,
yeah.
to do the same query 25 times, you know?
When you do...
Well, say you want a menu item of all your categories.
So yeah, cache it.
For each of them, you have
Cache it.
25 queries.
Cache it. Absolutely. You're right. So it's the question is the read-write, and this is precisely why the path is hard-coded in. But you have to really make a question if what's really more important. And by the way, this is a very, very, even if you do 25 actual queries, these are very, very inexpensive queries. So if you're telling me I never update my category tree, maybe. Even then, don't put it in here. Put a path table outside a type of hashed table that you can easily look up. But the other option, of course, is cache it. Absolutely. Next item is the level item. Very important. You want to know how deep you are in the tree. Again, very simple query. This is not like rocket science. It's essentially you're getting all the path, and then group it. You're getting the path and you just group it by the ID on a counter and group it by ID. Okay. Same thing goes with parent ID. How do you find out what your parent ID is? And again, this is going to be implemented definitely in FOF, and I assume that with the Google code, this will be, I hope, implemented in core as well. To subselect. Where you're essentially getting the closest, you're limiting the closest ancestor, which is then automatically the parent. So all these computational stuff, maximum depth of your what is the longest path in your whole hierarchy, and all these slides will be available afterwards, so you can have the code afterwards. Then the other question always is inserting a node, right? Which is one of probably the more expensive queries that you can make, or at least statistically, you're moving at least half the tree. Okay, because so it depends largely where you enter that node. But what is happening is that you have to change. If you're putting in all to the left, you have to change everything to its right. Always everything to its right. Okay, so if you just add one here, that's a very inexpensive addition, right? Creation, because you're just continuing the numbering system, and then all that you have to do is update these. So essentially, what we do on a computational level, we define what the spectrum is that we're going to insert. We're creating a hole by moving everything here. Adding two. If we're adding one node, that means we're adding two values into the tree. So we now have the scope of the tree that we're entering. We're adding that to the right of all the values to the right of the node where we actually want to enter this, right? And then enter it, the end. So computationally, it's maximum half of the tree. Again, a bit of a data overload. If you actually have questions, I'm open, I'm here until Tuesday. So you can even stay one day longer, and we'll discuss it. Let's now talk about some other stuff that we can do with the database, which are unfortunately sometimes overlooked. There's a common insert that we have in lookup tables, especially for fixed items. Product numbers, part numbers is my flagship example here. We have a part number, we have unit price, and a whole bunch of other stuff, and we're entering this, and let's assume that we are doing an index on part number. This is usually what we're thinking of, right? And now I can look it up by part number, right? So I'm looking the unit price from whatever table it is, where the part number is my part number that I got in, okay? So there are two problems. One is a speed, so it depends on how large this table is. It actually might be a very heavy and expensive search. The other problem is data accuracy, right? And that we all know that because you have a person that types the part number in with a dash, without a dash, or whatever it is, so, or with spaces. So the first item is, of course, to just eliminate all white space and concat the whole thing, which then gives me somewhat of a better idea of data accuracy. But the speed is still left. So until very recently, what I always suggested was to convert the part number, which is a varchar, into an int, because int lookups are very, very fast for MySQL. So essentially what I did is a CRC32, which returns an int, whatever the int is, and we'll get there in a second what the problem is with that, and have an additional column that is now my int value. And when I'm looking up where the CRC part number equals my new CRC value. So that's a very, very fast lookup. For singularity, due to the fact that CRC32s are returning integers, oftentimes you have collisions. So if you have a large data set, you can have the same CRC number for various different values. So in this case, what we always do is add the original query in as well. And then the index is CRC part number concat, comma, part number concat. Problem with this is 32 versus 64-bit. And this was a real problem where we did a whole batch pre-calculation on a machine that had a 32-bit compiled PHP version, CRC32 version, versus the production site that had a 64. 64-bit is not the same. Int is not the same thing as a CRC32. The answer is, thanks to Nick, a SHA implementation. So it's just a regular hash. And again, due to the fact that these are 40 characters, so it's a char the field itself is a char 40, so it's a fixed field. Indexing is very, very, if you have it indexed, the lookup is very, very fast. So it's exactly the same thing as the CRC32. And you don't have, due to the fact that it's a significantly more complex number, the collision occurrence is almost nil. Okay? Yes?
But why is that fast when a 40 character
Because
string index?
Fixed. Oh, so what you want to do, what you want to do is on here, not 40. What you want to, because I don't know if I have an under 40, a nulled index is not good either. So on the less than 40. I'm telling you. So, but what you want is in theory a substring. A substring, whatever the index is on this. Yes, I hear. But that depends on the data set that you have.
Of course.
So, whereas a SHA, you exactly know. So as an example, Japanese characters. Right? It's not indexed. But with a SHA, whatever the calculation is, even if you can't do anything with the calculation, but the index is correct. Right? So again, you have to think not our use cases, you're absolutely right. And the data set that we are usually working with, yes. But for real performance and for a wide array of implementations, absolutely. So the question was, in theory, you can just index this on a fixed index. Let's say six characters wide, or 10, or 20, or 40 for that matter, which is exactly the same thing as the original SHA value. The other thing that oftentimes occurs is contentions. So on high frequency websites, we have run into this quite a bit, especially if we are doing some reporting. So high contingency, let's say for simplification, hits counter. So this is the regular implementation of it. We have a hit counter table with an integer, and we insert into this hit counter an original value of 0, and then each and every time the page is getting loaded, this is getting updated. We just add 1, and then we do a select count. This is a bit more complex version, but significantly higher availability. Essentially what you do is instead of having just one slot that you have to update, which means if somebody else is updating at the same time, you have now contention, which means now you have to do a whole, like MySQL has to do a whole bunch of other stuff. You mitigate it by assigning a whole bunch of slots to it. to your counter table. And you randomly enter it into any of the slots. So on each and every update, let's assume you have 5 slots, you're randomly updating one of the counters. And then when you do a select, to find out what the count actually is, you just do a sum count of all these fields. So the contention is always divided by 5, or how many every slots you actually assign. So the truth is the rand is not really random, so performance may vary. And if you have more than 4 hours of whatever, you have to see the doctor. But within the understanding of what the concept is, this can actually solve a whole bunch of problems. Let's talk about indexing, which is my last topic. We discussed this, right? The select star from left minus right, and we changed that to a specific field because we should get only the data that we actually need, and not just random data. And then we discussed to move my indexed fields to both sides of the equality sign. This is what you were talking about, Hans, Beat, right? You can do a subset of an index. This is super important. Very, 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 very important. Especially as an example for sorts. If you have articles and you want to do it sort alphabetically, right? So you don't really look up any type of value, and it's not a full text search. You just want to sort it alphabetically. So all that you have to do is assume that, say, within the first, you can determine the alphabetic order within the first 10 characters. And all that you do is on that alias table, you add a key that is limited to 10 or 6 or whatever it is. And now all of a sudden, the sorts are super fast. This is not a lookup index. This is a sorting index. Right? Does that make sense? So this is very important. Question. Create table C1, C2, C3, and we have a whole bunch of keys. Which of these are the correct ones? And it's a tricky question, because it really depends on the data that you're using. Which means the point that I'm trying to stress here is you really have to understand what the use case is for each of these items. As an example, select credit card from payment where staff ID equals 2 and customer ID equals 584. In which order do you have your index? Right? So it depends on specificity. Which field will return the lesser amount of data? Okay? So if we actually don't know it on the table, and we actually build that index in afterwards, you know that if you do it on staff ID, comma, customer ID, you'll actually first look up 7,992 rows, and then condense that back to 30, right? Versus customer ID, comma, staff ID, which now you get a data set back of 30, and now you just have to match 30 against the staff ID too. So, yes.
Are you sure? Because from what I understood in MySQL is that when you have multiple keys, they're actually just appended to each other, and then there's a one which can be done either on the first part or on the.
So say that again. So the keys left to right.
When you have, for instance, 2 keys.
Yes.
In the index table, you have only one entry. The 2 strings are just appended
Yes.
to each other. So if you have the index in one way or the other way, for such a query, it doesn't make any difference.
That's actually not true. That's not correct. So it's a left to right index. The question is whether or not you can have. This is, by the way, in some highly optimized code, you actually see double keys. by the way, Sphinx uses precisely that mechanism. So you're right in 5.6 and on, but I don't think that's what you were referring to.
It was that way.
Yes,
Maybe I'm not sure.
correct. So my 5.6 now, all of them are exactly the same. But I think that we have to, again, the question is, so we'll get there in a second, because there is a point at the end, which is you always have to check it out against your data sets. Roland was doing some testing on his data sets, and instead of an option of dropping a key, adding a key was significantly better, right? Absolutely, but try it out. Due to the fact that we're all developers, we definitely have visited a dating site. So this is near and dear to me now. Several? Who said several? Very simple. It's a profile. So you have the ID, you have sex, you have age, etc., etc. Usually, what we do is a range lookup, right? This was written a long time ago, because this is not my search profile between 18 and 25. But that's essentially what we usually do, right? We go, whatever it is, price, range between X and Y. This is horrible for MySQL. MySQL cannot deal well with range lookups, regardless of the index. Which means if this is perfectly indexed, the between itself kills the indexing. So let's table that question for a second and come to the next question. Is this a good key? Sex and country? Why? Because the specificity of it is you assume that at least 50% of the table is getting returned statistically. Or let's say there is male, female, and other, and then you have 33% statistically. The answer is use the non-specified as well. Coming back to your point, Beat. But make sure that you don't return an empty result. Have the in always, regardless, even if you're looking, because the problem here is with sex and country, maybe you're actually not looking. You're just looking to hang out with a friend on this dating site, whatever. And you don't care whether or not it's male or female. Right? So you don't enter that into your search query, which means if this is not in the search query, this key is invalid. It's not even looking it up. It needs both sex and country. So in order to make sure to mitigate that risk of somebody that doesn't put in sex, you just add it to each and every query because it's a very, very inexpensive lookup. So with that in trick, we can use almost everything that you can actually specify in ins. By the way, in the ins, you can actually do a subselect, and even if you have a large table, do a subselect, better even a queried subselect of all the values that you have. Right? Does that make sense? So even a regional city, you might have a million cities. The in does not care how big it is. So if you actually put that out, do an explain, or actually show the code that actually comes out, it is ugly as hell. Because you will have like a select statement that's super long. I don't care. MySQL doesn't care. In is a very inexpensive, significantly less expensive than a range lookup. Okay? So that's the question of our range lookup. When we have already predefined range lookups, like age, use the same trick. If you due to the fact that we know it's going to be a range lookup between 18 and 25, don't do a between, do an in. right? And all of a sudden, you don't have a range lookup anymore. Yeah.
It's a particularity of MySQL, the in, because in other database management system, in is expensive. You need to split in volume.
Yes, it is expensive, but it's less expensive than a range.
Yeah.
Right? I totally agree with you. If we can come up with a better way of making this query without using an, absolutely, go for it. No question. But in comparison, you have to, you just have to optimize whatever you have, or the data set that you really have. So I'm letting you go early because I know that I'm standing between you and lunch. Try to make, whenever you can, try not to think of the last item as part of your content tree. There shouldn't be a content tree ever. There should be a category tree. And then there should be content items that are assigned to a organizational tree. Right? We always use content tree, right? Content tree this, content tree. What I don't have conceptually, it gives us the wrong impression of what content really is supposed to be. Content is content, and an organizational tree is an organizational tree, yes.
Shouldn't you have the nested table tree as a separate table and not have a big row attached to each?
Yes.
Yes.
But Chad is here, so I have to whisper. I don't know. So I'm just
Question.
singling out.
If you have multiple such nested trees for different things, should that be a single table
No.
per type? Or
You-
do you
you-
have one table for each nested?
So this is a good question, and I don't have a good answer. So I'm Jewish, so whenever people ask me, oh, what do you think? And I said, it depends. So it really depends. But the idea is, in theory, you can have a hierarchy tree that really doesn't care of what type of hierarchy it is for, so the ACL and category manager and et cetera, could all be under the same hierarchy as different subtrees of the big root tree, right? It's a possibility. Maybe code management is a bit more difficult. And then extendability is a bit different, because now all of a sudden, maybe. I'm not saying yes. I'm just saying it's a very interesting question that needs to be asked. And on a project level base, needs to be decided whether or not it makes sense or not. So for a Joomla, yeah, sorry. No. So in the Joomla world in itself, I think it's would be very hard to implement something like this. To change the current ways, because change is hard. Change is hard. But for a project that you do with a whole bunch of different types of categories or nested sets for different types of venues, absolutely. And all of a sudden you have, there is one caveat to this. And that is depending on how big the tree is. Because moving and inserting and deleting are very expensive or somewhat expensive transactions that you're making on the database. So maybe that's the one thing that I would say against one big hierarchy. Sorry, Chad.
So you pointed out some design issues in Joomla.
Yeah.
How feasible is it to try to start correcting those in dealing with things like backwards compatibility and whatnot? Is there a way we can start to try and improve this? Because I think there's some significant issues.
Right.
What is the path to try to resolve that for improving Joomla?
Yeah. So this is the sore point. The backwards compatibility. If you're actually using the path, which I don't know whether or not they do. Extension developer. It's not core. Core is no problem. Core is no problem. That's easily rewritten. But the outside extension developer, that's going to be the problem.
And we could make the improvements on the JTable nested, and of course for backward compatibility there is the all, but in the core we are doing it right.
No, but you can't, as an example, you can't delete it anymore. You can, no, correct, but then oh, I don't have that. Seriously, I don't have it.
For the path, for example, we could get the path.
Yeah,
and
yeah, but
say this is the correct way.
just to look inside, but you still have to contain that logic that still writes that path, because the truth is, if a component developer just uses path as the breadcrumb mechanism, all of a sudden you don't have that path anymore. Now, what you really can do is create a trigger, and on every lookup of path, you just send it to the right way, but then we go into triggers. And permissions. Permissions. There are a whole bunch of other things. As an example, indexing, right? If you do a batch insert, you should always, when you do big stuff on the database, always drop all the indexes and rebuild them afterwards, after you do the batch, because each and every time you're rebuilding the whole, starts with C and rhymes with rap. But that's really what it is, right? You're doing hosting issues. So the truth is, if you don't have a drop index permission, you should switch host.
Yes, how does
But
it also translate to PostgreSQL? Because Joomla supports more than just MySQL.
So, can I do something off record here?
Well, I wish it would go, but
No, because it actually doesn't work. Postgres doesn't work. But I'm not. After the talk, after I'm off video, I'll tell you what I think about the implementation of Postgres. Anyway, so yes. Yes. Good luck. Good luck. Happy coding. Lots of beer. Yes, this is MySQL specific, but the truth is it's translatable to almost any SQL language. So fine, it's not called between, and you actually have to write it out like greater equals than whatever. Fine, I understand. But I'm just trying to seed the idea that you can do stuff in better ways.
yeah, I'm just going
Right.
on what Jeff said, that how we can improve the core, but then it
Right.
just needs to be more than just MySQL at the moment.
Oh, that's fine. Again, all these are written here in MySQL, but none of these are MySQL specific. Even better than that, the truth is, Postgres actually would do an in type better than MySQL. It's better optimized for an in lookup. And it has exactly the same problem with range lookup. That's not MySQL specific. It is, MySQL is probably gets the biggest hit on it, but yeah. The other thing is, when you do, and I don't have the slide for it, I'm terribly sorry, but one of the other tricks that is very, very important is when you do a limit lookup, what we do is we do the query, the whole query, select age, gender, picture, blah, 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 the whole shebang, limit 100,010, because you want to get the last page of your 110,000 people that you have, right? Does the query, you understand what the query is doing? I'm just looking up. I have a pagination. I'm looking up the last page. The way we do it is 100,000, but we get just the last ones, okay? This is a super expensive query, because you're getting the whole data set and then just discarding what you don't need. So you can get on this query alone, in a normal application, you can make a 18 meg data request, of which you're discarding 17.99 megs. The easier way to do this is do a subselect. So you do the select all the fields from select ID, which is the cheapest lookup, limit on this 100,010, and then you get only on that subset the whole data. So you're still making a query of 100,000 and then discard everything other than the last 10. But you're not getting the whole data set. You're just doing it on a very small set. Yeah, we're good. So apparently I'm reminded that you're very hungry. I understand. Me too. Yeah, so. Oh, so utilize live queries instead of saving it to the database. That's the path thing. Create summary table. Somebody here? Yes, that was you. Absolutely. If you have to have it, fine. But then put that outside and do all the logic on it. And then even better than that, now all of a sudden you can have cache validation. You don't have the cache validation problems that you have in normal cases. Utilize live queries instead of saving into the database. Simplification columns. So whether or not that's the simplification column or the simplified index, as Beat said. And choose an indexing strategy, again, according to usage. So you know better what your data is doing than anybody else. Don't just rely on left to right or whatever it is. Just try it out. And make sure that you utilize live queries instead of saving to the database. And that's it.